All right, welcome to exam 1 review session. What do you want to do? Let's look at this first. Here are the topics. I didn't animate it. All right, well, that's great. Look over this guy. I'm going to use the laser thing. Lasers. Fundamental kinematics. You know those are. Fundamental. You know what I should have done? I should have printed out equation sheets. Shoot. I can't print from that. The equation sheet is your friend. You know that there's an equation sheet?
Yeah.
Okay. I wasn't sure if you didn't attend the first 2 classes?
Yeah.
Okay, so I just want to make sure. There's some things that maybe you hadn't heard of or so. Make sure you use that as part of your preparation. We have the fundamental kinematic equations. We could write those out in a second. Projectile motion problems, constant acceleration, which is projectile motion is really a specific constant acceleration problem. We have relative motion problems, constrained dependent motions. Those are most pulley problems. Rectangular coordinates, kinematics. We learn a coordinate transformation, and we have path coordinates and polar coordinates. Those are like the main topics. I would advise you, if you're to any class that you're doing and you're about to take an exam, try to make a list. Like make a list. Don't spend forever. But part of your first thing is trying to organize, and you might even make a list that's more exhaustive that has like types of problems, subcategories of this type of thing. I found this to be very useful. Especially for myself when I was taking PhD classes, because it had been 20 years in between taking my master's and taking the PhD. It was really a lot of stuff to try to process. Really good idea to organize and write down all the different topics that you're going to be covering. I guess we'll go there. So there's this section of your equation sheet, and it's got kind of skewed out here a little bit, where we have all of the different things. Like right up on top. Do I get to another slide? No. Right on top where we have the fundamental kinematic relations. Then we have just uniform or constant velocity position. Here's constant acceleration, velocity, and position. And then here's the wild card. You can't really read this very easily. It's kind of messed up. But we have relative motion, either with just 2 particles in line with each other, or we could have relative motion in 2D or even in 3D by having, if you know a reference, and then you have the relative position, you can find the position of the other thing. The same thing with the velocity, and the same thing with acceleration. We have our path coordinates, and I think I lied a little bit right here. I think there's a little bit of a liar thing going on right there, because and the things all screwed up here. I don't know where it would have been. This seems like it should be really old information, because I still have stuff from Newton's second law. So there was several years ago, we did cover stuff on Newton's second law. Let's see if we can. But on exam 1, but I decided to restrict it to this right here. Okay, right now. And that's easy to read. That's true. Yeah, sorry about that disjointed thing. But we have our tangential coordinates right there. We can see velocity is just a magnitude times the tangential unit vector. And then acceleration is 2 parts. We got the tangential, which is the change in speed, and the normal, which is the so-called centrifugal acceleration, v squared over rho. And then in polar, we have 2 parts. We have an r dot for the radial component, and then we have an r times theta dot for the transverse component. And then acceleration, now we got the extra parts. Like the r double dot minus r theta dot squared, and that r theta dot squared, you can always associate that also with centrifugal acceleration. And then we have r theta dot double dot, and then plus this r 2 times r dot theta dot, and that's the Coriolis acceleration. All right, so I have posted on Blackboard a slew of stuff, which is a great word, a slew of things. Make sure you get the most out of this stuff that I've provided up here. We've got exam prep, and here's the previous exam review sessions, just like the one we're doing now. So you get some of those. We got practice problems. These are ones I took from the Coast Guard Academy. Would have been a lot easier if I've been there. I think I taught dynamics 4 times, maybe I think 4 times. So from the years, I think only 3 of the years are there. You may see spring of 17, that's what that means. Not that you care. Some of these don't have dates on them, okay. I thought they all did. Spring of 16. So these are actual exam questions that I had, that had been asked. But there's only like 14 of them, so I wanted to do more. So I went ahead and I found this Missouri University of Science and Technology right here. I thought this was a pretty cool find. If you go to that link, you'll see here's a bunch of exam questions, like a ton. And these have like, here's exam 2 that he had. Of course, we only care about exam 1. They don't match up exactly, but here's a projectile motion, and here we go, and they might do something a little differently in their solution. Here is, let's see which one, I think this might, here's something we don't ask, I should point that out. Not everybody asks, but I don't have the equation on the equation sheet, so we're not going to use it. But there is an equation in the book for radius of curvature, which if you have it as a function of like something, you can take the derivative of it. But we won't be doing that, just let you know. I didn't ask any questions along those lines, so it's not on our cover sheet. So here's the dependent motion problem. So you can test yourself, and these might be a little easier, probably than mine. But it's it is the action of trying to test your brain and see if you could do the thing. Sometimes I will combine topics, but not. I don't think it's in such a way that it should be a hindrance to you to do it. It's just the fact that you're kind of saving yourself a little bit of time by doing 2 parts. But also, I try not to make it overly complex. But sometimes I might have something in there. Like I might have to do like a path coordinates with relative motion in it. I want to find the thing that you have to find. So anyway, that's the spiel. Someone should remind me of this. Or here's projectile motion problems, because I also mentioned there's like just tons of combinations. I will not be asking either of these 2. This one actually is pretty darn hard. When you're actually trying to find the angle, it can be a really challenging problem in some of these. If you're ever really curious, I can show you some other time to do it. A lot of times there's just a math trick. There's a math trick to get the unknowns onto the thing, but it's not necessarily easy, because you'll have like a tangent squared plus a tangent plus another number equal, and like you said, equal to 0, and you can turn it into a quadratic, solve the quadratic, replace you replace tangent of the thing with z or something like that, and then you solve the quadratic for z, turn it back into a tangent, and find the angle. But there's going to be 2 angles. There's 2 possible angles, so that you can see right here we have 2 possible little paths. That's why it's a quadratic, and you get 2 answers. It's interesting. Anyway. But that was also information on there. But I would try some of the other ones too, because projectile motion problems, they seem easy when you see the solution. They're not so easy if you haven't done a particular combination yet of them. They all have pretty much the same idea in their underlying thing. But remind me that I want to release this in class. I'm going to release it 2 days. So on Tuesday evening, I will release this the solutions to the practice problems. Why am I waiting? So you do the problems instead of reading these. But some people, that's all they'll do. They'll just read these solutions, and then they will not succeed. And I do want you to succeed. So I will try to be that self-discipline. I'll be your self-discipline. So what would you like to work on? Would you like to just randomly pick a problem? You want me to pick a problem? You have a problem type that you would like me to solve? We can just stare at each other, whatever you want to do. A homework problem in particular?
I had a question about the second question on homework 5.
Okay.
Why did you use the angle did you use the angle of the train to the source and not the angle of the source to the train? So why did you measure the angle at the train and not at the source?
Well, it depends on your reference. So let me go to the solution. I could have messed it up. Let me think about it for a second. I think it's going to be okay. I think what I did was okay because I did it. I'm sorry, that was funny. It was funny in my head. So what I did is first I measured this angle. What angle do you want to measure? I guess maybe I'm asking.
The other angle.
This angle?
That would be the same angle as the one I did, just different spot.
Yeah. Well, it's mostly because this angle right here should be the correct one, right?
Okay.
This one right here should be the same angle as that?
Yes.
Okay. Well, so that's the reason why I used it. Like, this would be is this the angle that you were referring to?
Yes.
You could totally use that. You'll get the same result as long as you make your transformation thing correctly. Does that make sense?
Yeah.
All right. Did you follow this, or what I have just said? Can you be good? Is there something you could benefit from it? What I just went?
No, I think I got that.
Okay, cool. All right. All right. Does that make you? I mean, it's going to take it on faith. It's good that you're skeptical. I could be lying to you.
I'm trying to figure out because we got different answers, and I got the same things for the R.
You know, I make math errors all the time, so it could be about that. You know? There's nobody for me to really look up against, because I took a problem that existed that was simple, and I put an extra little thing on top of it so that I could get I wanted to combine the path and the polar coordinates into a thing. So you can expect to see possibly something on the exam where I combine something like that, the path and the polar. Because now I have this opportunity to get a 2-for-1. I can measure. Do you recognize that? And then also there's a transformation. There's like 3 things like that. And I don't think it's that hard of a problem. I don't think I could, especially because I didn't make crazy angles away from that. But then once again, not once again. I should mention. Probably haven't told you. What I generally do is I'll write an exam. Well, I don't know how the hell I'm going to do this weekend, but I'm going to do it anyway. I write an exam, and then I take it. I pretend I'm a student, and I don't skip any steps. I try to have a little bit of amnesia, and work through it. And I time myself, and I try. I see when I'm done. I've usually found, oh man, I got to get rid of some stuff because this is it's too long. And usually the time I aim for is anywhere between double, where it takes me half the time, or even 1/3, where it takes me one third the time. So either half or 1/3, somewhere in that range. If it was a freshman class, it would be 1/3. If it was a sophomore class, it's usually call it like 3. Let me say call it 3 times. Sophomore class like 2.5 times. Junior class 2 times. That's usually mine. And then I don't. Senior class I don't. Still 2 times. So I don't like it. So. Doesn't always work out all that well, but my goal is to have at least in maybe a class full of 10 people, have 2 people finish early. But I don't achieve that very often because people are very methodical test takers and use it the entire time. And just let you know what it will be like, what you can expect. All right, so we got. Asking any call-outs, requests. This is what I was looking for, requests.
I'd like to see a relative.
problem.
Okay.
Just trying to find like more on that.
All right. Well, let me help you. Not a lot in this book of relative motion problems. Sometimes, like even here, I kind of robbed that one for the example in the class where we're doing the vector one. I think I gave you this one, didn't I? Did I assign this one to you? We have this guy right here. I don't know if I remember him, how to do him. Here's a relative motion here. I think this is a dependent motion and relative motion one here. Is it? No. It has been asked before to try to get the relative motion and the dependent motion in between these. This one really is a very confusing problem. I think there was a trick to this too, as I recall. I hate the trick problem. This is a relative motion problem that's been asked a bunch of times. This is sort of a relative motion problem. I'm going to get upset if I can't do it. Anyone in particular? You want to try something?
Can we do that last one? The 11.132? Yeah.
Sure. Department store display. And is the train moving is the train that's not horizontal either, but they don't tell us anything about the train. Well, maybe there isn't information, they just don't have it labeled. Yeah, they do have. Okay. As part of the display, a model train D runs on a slight incline between the store's up and down escalators. When the train and shoppers pass A, boom, right there. The train appears to the shoppers. Okay, that's a crazy one. The train appears to the shopper. Which shopper? On the up. This guy on the up escalator to be moving at an angle of 22 degrees with horizontal downward. Okay, with horizontal. And to shopper on the down escalator C, this is a logic problem, by the way, to move upward at an angle of 23 degrees with horizontal and to travel to the left. Knowing that the speed of the escalators is 3 feet per second, determine the speed and direction of the train. This is like crazy. This is like word problem on steroids. Okay, so there's got to be, all right, so right here you're experiencing, I do not know how to solve this problem, but we're going to try to find our aha moments somewhere in here. Kind of try to organize our brain and organize our thoughts. So this is like test-taking, an incredible test-taking example. So I'm going to go like, what's the givens right now? Okay, well, some of them, let me go for the first phrase. The department store display, the model train runs on a slight angle. When the train and shoppers pass point A, the train appears to the shopper on the up escalator. That's going to be, let's name him B. So he's B. It appears to them. So it's going to be the train, which we're going to call D, with respect to B as a vector. It appears to that, D appears to B, so with respect to B, is going to be moved at a downward angle of 22 degrees. So it's going to be VD with respect to B as a variable, right? As a thing, right? But we don't know what it is, right? So, but it's going to be coming down, move downward with an angle with respect to horizontal. So I can't decide, is that going to be that way or is that going to be that way? When he gets to right here, he's coming up this way, but it appears he's going down that way. All right. So I think it's going to be going this way right there. That makes sense. to me. That right there is going to be the 22 degrees. All right. The next is with horizontal, and to a shopper on the C, right? So she is going to be C. It's going to be doing an upward angle of 23 degrees, right? So it's going to be VD with respect to C is going to be, this is a VD with respect to C. It's going to be going this way, I believe, of 23 degrees and to the left. Knowing that the speed of the escalators, right? So if the speed of the escalator is going to be the same as these guys right here, so VB is going to be actually be 3 feet per second upwards. At 30 degrees. You agree with that? And that VC is equal to 3 feet per second. I hope we can solve this because it's going to make it really sad. Because that's 30 degrees right there. Okay. So this is the given. And I should write out what this is. 11,132. And this is what the 10th edition, 12th edition. 12. There's that. And we want to go find, determine the speed and direction, VD. Whee! Okay. So, we might be able to do this with components, but first I'm going to try my best at writing out things with triangles. We should note that we're not always, sometimes we're given redundant information. We might be able to find out the answer without all of this. Doesn't seem likely, but it might be. Let's take a look at, we didn't do many of these problems, so that makes this an exceptionally difficult problem. So let's write out the velocity of D with respect to B is equal to the velocity of D minus the velocity of B. That's just a fundamental thing, right? In order to do the triangles, I prefer to have an additive one. I don't have that one kind of well memorized. So we know that the velocity of D is going to be equal to the velocity of B plus the velocity of D with respect to B. So we could draw out the ones that we know. We know that VB is going upwards at 30 degrees, VB. So I'm going to draw that like, here's my horizontal. I kind of like having the protraction. These are inferior to the ones I gave you. Did I give you? I didn't thermal. Okay, but I didn't in dynamics. Okay. You only get one, yeah. But if you need another one, just talk to me. Anyway, so I kind of like these. So here's, I don't know if I need this whole thing, but there's a 30-degree line. So that's going to be my VB, and I can actually give it like if I wanted to, I could actually go right here with scale it right there. Here's one. So 1, 2, 3. There's a 3, and here's the 30 degrees right there. Great. We're going to add it to B. Oh, I'm sorry. No, this is what we're going to add to. So VD right here. So we're going to add this to here. So that always goes to nose to tail. So the tail of this thing is going to be right to here. And this one said that we went down to 22 degrees. So it's going to be kind of like from horizontal, right? So here's this. This would be 30 degrees. So this one is going to be a tight one, but down like that right there, right? You're in agreement? So just right into here. I mean, I've exaggerated it, but it's going to be tight in there because there's only going to be 8 degrees in between here. But it's going to be coming this way right into there. So we still don't know, because we don't know the magnitude of this, and we don't, and so we don't quite know what the direction of D is going to be. So I guess we're going to have to use, because it could be something like, it could be either this way, it could be horizontal, it could be downwards. I think they're kind of drawing it up like it's upwards, aren't they? It's not given in the problem, but maybe so we can't quite establish it, right? So that was the first one. Let's do the other one. We can just from our looking at this say it's going to be C VC plus VD with respect to C. That is also something that we're going to know based on this information, and we could go like let's see. I'll draw it over here. I think one graphical thing that we could do already, I could see, is we could kind of blend these two things, take these and superimpose them on top of each other at some point if we wanted to, and that would like kind of solve some of our problem here. But let's see, from 30-degree angle, that would be that. So I don't think I did that right. Oh, I guess I did. Didn't look like 30 to me. All right. So and we know that that's going 3. So here's our 30 degrees right here, and then we're going to add C to it. No, this is C. So we're starting out with C. We're going to go D with respect to C. D with respect to C is 23 degrees. So that, once again, is going to be up. It's going to be, right here is 30 degrees. So it's going to be 23 degrees. So there's going to be like 7 degrees in between there. So that right there is going to be somewhere around here. Let me write this right here. Here's V D with respect to B. This is V B. Here's V C, and here's V D with respect to C. So we have to kind of nail these and see. It's going to be, I'm guessing it's going to be something along these lines right there, and something along these lines right there. And this line must equal that line right there. So I don't think the graphical method is going to get us anywhere, but it's going to help us confirm the thing. So let's go and switch to that VD. Let's write the thing out as we know it to be. Okay, we have to get our signs correct, and let's go components. This is definitely a challenge one here. Okay, so we're going to take these two equations and break them into components, right? So what we're basically, what we could do is we could solve for this magnitude right here. If we could solve for the magnitude of VD with respect to C, wait, they're not the same. You know what? The vertical component should be the same, though, right? No. I'm trying to see what trick is at heart. I'm trying for my aha moment. This is a challenging one. Could we go? We know this equals that. So let's go x direction, and we'll go VC. It's going to be 3 times the cosine of 30. All right, so I don't know why I went to C first. I should have gone to B. Sorry, let me go to B. We have 4 equations and we have 4 unknowns, basically, here. The 4 unknowns are the x and the y of this and the x and the y of that. Yeah, but really only have 2 equations now. Gosh darn you.
Can you do your equation for your sheet up a little bit?
A little higher? Well, no, what do you mean up?
So that we can see all 4 things.
Okay, I'm sorry. You said up, but I gotta kind of go back. I gotta go down, yeah. At least I'll go B first. That's gonna be positive. And cosine, I have that right, cosine of 30. And then D with respect to B is going to go negative. VD with respect to B is going to be negative and make it cosine of 22. Yeah, I can go all the way back. And let me see. Okay, so that's this one right here. It's going to be equal to VC. Yeah, there's also 3 times the cosine of 30. So that's going to actually cancel each other out, aren't they? That guy and that guy. That's interesting. Okay. And yeah, so we only have 2 unknowns. We have 2 equations, 2 unknowns. My bad. 2 equations, 2 unknowns. We can do this. So we have plus VD with respect to C. And that's going to be negative in the x direction. Yeah. This is how to solve it. I got the aha moment. I hit my aha moment. Are you with me? I lost me. Evan, have I lost you? Okay, cool. So did you guys figure it out before me? Are you just letting me look like a fool?
I misread something you wrote down, so I was like going, how are you doing? So,
But you understand it?
Yeah.
No, okay. But could you figure this out on your own now?
yes.
You could? Okay, cool. I feel like good. All right. And in the y direction. So if the people at home, let's pretend they can't. So in the y direction, what did I start out with? VB. VB, you're going to go 3 times the sine of 30. VD with respect to B, that's going to be negative, once again. VD with respect to B, sine of 22. We're going to have VC, my brain's not working, minus 3 times the sine of 30. Okay, so good, that's going to add with that one, right? And then D with respect to C, it's going to be plus VD with respect to C, sine of 23. So in our first one, we're going to be able, from this, because those 2 things cancel out with each other, we can find either one. Both of these are negative, so that's good. So VB with respect to D is just going to be cosine of 23 divided by the cosine of 22. times VD with respect to C. So we have 23 cosine 22 divided. So we get 0.9928 VD with respect to C. And now we can replace it back into one of these and find the unknown. So we go, this is going to be 2 times 3 times sine to the 30 equals, we have that one right there. So I'm going to take this one, I'm going to take 0.9928 times the sine of 22 times VD with respect to C plus VD with respect to C times the sine of 23. I bet one of those things would have canceled out. Maybe not. Sine of 22. No, it's the sine, so it wouldn't have canceled out. I was thinking cosine, right? Boom. And then 23 sine. I'm going to add them. All right, so this whole thing becomes 0.7626 times VD with respect to C. Sometimes I'll actually even write that down. There's going to be 6 times sine of 30. Shouldn't that be 3? Yes, 3. So that's 3. What? You can't see what I'm writing. 3. So, reverse those on there. Divide. So I say that VD with respect to C is going to be 3.934. What are these? Feet per seconds? Feet per second. And therefore, D with respect to B, its magnitude is going to be 0.9928 times it. So that's going to be 3.905. We've got to be careful with our sig figs here. They got, those numbers are pretty damn close to each other. So now I think we could find either one that we want from up above, right? So we could go back to the components. We go D with respect to C. So we go V. We still don't know the angle, do we? Interesting. We have to be kind of clever about this, don't we? What do you think? The next step? We have these, but we want the VD, but we don't know VD's angle yet. So I think what we might have to do is leave a space holder theta in for there and then solve it. Does that sound right? So if you go for either one of these, you can go, oh wow, that's tough. Now you get, the angle is an unknown and the magnitude's an unknown. It's like a math problem, but the math problem messed up. Am I overcomplicating this? VD. Yeah, I guess what I could do. Okay, so this is the easier way to go. I want more paper. Sometimes more paper helps me. Well, look at the difference in the color of these papers. No, you can't tell. All right. Let's go. We're going to break down this equation. We're going to break down each of these equations into x's and y's. So I'm going to go VDX is equal to VB. Okay, so wait. Where's, well, I'll just put it this way: VBX plus VD with respect to B, X, right? And same thing for Y. Yeah, so all we need is the dx and the dy. We're fine. Jeez. That was kind of stupid of me. That's right. So we could go v dx, and we could put a, we do actually, no, we don't know the signs of that yet, necessarily. We can guess it, but we don't need to guess it. We can go VBX. VBX is going to be 3 times the cosine of 30 plus VD with respect to B, D with respect to B, 3.905, that's D with respect to B, that's going to be negative. It's going to be negative times the cosine of 30, of 22, 22, right? So we can actually find that value. 3 times 30 cosine times, and then 22 cosine, and then 3.905 times, and then subtract, and we'll have a negative 1.0226 feet per second. And then do the same thing for the y. And so the y of VB is going to be upwards, so it's going to be positive 3 times the sine of 30 plus, and this is also negative because it's coming down right here. So minus 3.905 sine of 22 equals, so let's see. And this one's red. Does that mean it's in the back of the book? Can you take a peek there, Evan, if you don't mind? And 3.905, 22 sine times minus, whoops, damn it. I think I just screwed up, minus, okay. I get a very small number, 0.37.03. So if you wanted to express this, it would be a negative 1.0226 I plus 0.03716 J feet per second, but we probably want to get the magnitude of it. Is it, what's that?
It's going to be different because mine had, instead of 3 feet per second, it was 1 meter per second. So they're probably
Really?
different. Yeah, because my answer is in meter per second.
Did I read the thing wrong?
No, it was just different.
Why would yours would be like flying like crazy at 3 meters per second, you know?
No, it's 1.
1 meter per second. Okay, it's not so bad. I guess the angles should be the same, right?
Yeah, the angle should be the same. So that's just like that.
Yeah. So why? I wonder. Do you have the like international version of the book,
I don't know.
or is it different?
Well, in SI,
It says in SI. Well, read the bottom of the cover. Read the bottom of the cover. I'm just curious. Does it say anything about it's supposed to be in Bangladesh?
No.
Doesn't say it. Okay. Look on the edge. I see something white. Does it just say no?
No, I should say it's 12th edition.
Okay. Sometimes there's an international edition that's only supposed to be in developing nations. They're not supposed to sell them here. McGraw-Hill does that, but people get them all the time. I just bought like 4 of them. Shh, don't tell anybody. But we're recording this, right? So we got 1.0233 feet per second is what we're predicting, and then the angle of this should be the inverse tan of 0.03716 and 1.0226, 0.03716, 1.0226 divided inverse tan. Only 2 degrees, wow, 2.08 How do we? Is it okay?
2.07.
Okay, so I probably did a sig figgy thing there somewhere. But that's going to be to the left and up, right? Because that's negative here in the x direction, positive here. So the answer we could rewrite out to there is going to be equal to 1.02. We go look another sig fig if we want, and then up 2.08 degrees. And let's see, it is in red. I'm not sure what red means. In terms of the, this numbering thing. Sometimes that means you could do a computer problem, or I don't know. Oh, it was challenging. Took a lot of time too. Sorry about that.
It's very wordy, Jason.
Yeah, that's not a good exam question. It's, for a couple levels, some of it is because everybody's going to hate me. But I don't know if that's necessarily should be my motivation. But I really don't want to be. I don't want to be hated. But 132, not in here. You bastards. So I could check the holy hell out of that, sure. I don't think, but then I would have to turn the Chegg account on for this computer. They only let you have 2 computers.
Oh, you can change that.
Yeah, no, but they only let you change it like once a month.
Really? I could have sworn you could have done it.
Yeah, they're clamping down. Let me does it. Okay, so we're back recording. And Beer Johnson, in the 12th, we're in the 12th edition, right? So I think this is the 12th edition. Okay. And we were on problem what? 132, something like that?
11. Yeah, 11.32.
Yeah. Yay, look at that. Got the right answer. Let's see how simplified they made theirs. Ooh, look at that. See, I was telling you, one of the first things I did, I always try to do graphical, because you could try to think your way through it, and it did help a little bit. But you can see that right here was the solution, right there, the graphical. And I think they show the graphical approach right there. And they're doing law of sines to try to find their, with the unknown angle. They have the unknown thing and the unknown angle, so they have these 2 equations, and with that, they're able to find the thing, all right? But then they have this right here, alternate method, and this is basically what we did, right? We stabbed what we had for our velocity, and they broke it down into x and y, so the I and the j. And then here's the unknowns, right? So they put this U1 and U2, but that's what we did for our magnitudes for those. And then they set these 2 things equal to each other right here, and they solved for U1 and U2. And then once they had U1 and U2, they were able to solve for the components. So they did the identical thing that we did. I think it's an excellent problem to have looked at, not necessarily just because we're not going to do relative motion of anything of that complexity, but in terms of just seeing how to solve a problem that you don't know how to do, and just describing the thought process. The ever important question that every student should be asking: how did you know how to do that? Well, you didn't know. I didn't know. But I figured it out through just applying this stuff, and that's what we want to get to. All right, so we need another problem. A type of problem is a good place to start.
Can we do a polar transformation problem?
Sure. I'm glad you asked, because if you didn't ask, I wouldn't know what to do. He amuses himself way too much, is what you were saying. What they're saying on Rate My Professor. Burning me up on Rate My Professor. Here's one I wanted to do. It's hidden somewhere in my, or it's in a video. It's a great problem. We also have that problem. We also have this problem. I've asked problems that are similar to that. We also have this problem, right? So here's our choices. Let's see, is there any more? There's also a section in here. Are we in the section already? We might be in the review section. Are we in the review section? Bless you. No, we're in the tangential and the polar. I think they combine. There's a review summary in here. I like these color-coded things that they're always doing here. Okay. Now they go purple. Oh, we also have review problems. So if you're going to go higher level, and you want to get like ace, you're trying out the review problems. This problem, I hate this problem. I hate it. It's really tough. Not that tough, but.
I don't like the way they did it in the PDF, though. They made the entire page.
Yeah, I see that. It was an accident, or they sabotaged it. Here you go. Here's another guy. Here's a ski jumper. That's also a puller. So what do we got? We have a menu. On the menu items, oh, we got this guy. This is fairly simple. This isn't too bad. This is also a transformation one with polar. This is one I don't want to do. Yeah, I don't like this. This is not so bad. This is one where you have polar and you have tangential. But it's easier because they've aligned this is the path. This is a path. L1 right here. And then we also have our ski jumper. Oh, and this one right here goes the other direction. Oh, you son of a gun. And I think this might be, oh, and also, there's also a, look at the jerk one they do, is they go backwards, because here is what the variables of interest are. That's not that bad. It's actually not that bad. The bad part is that then you got to get all that, and you get the original. You get the acceleration or whatever of. What's the acceleration? That's interesting. You get the velocity or acceleration of this ski jumper, and then you need to do the find out what distance it goes. So you do a projectile motion of the ski jumper. All right, if you don't decide, I'm going to decide. Wow. That hurts my feelings that you don't care. Was that?
Less words than the last one.
There's too many words. I'm an engineer. I don't want to read. I'm going to go with this guy. Okay? Cool beans. All right, so we won't have as many words. The airplane. Well, we have aerospace majors here, right? Evan, what is your major? Okay, cool. I have too many aerospace. You know what hurts my feelings about aerospace? We didn't used to have that program, but now we have a bunch of aerospace, and I think they would have been mechanicals. And then they stole. That's an unpopular opinion. That's how it feels to me. I feel rejected because what they've really rejected are the classes I teach, not dynamics, but the ME370 class. But I think I can get over it eventually. So we have an airplane, a poorly drawn airplane, and this is like a mile, 1 mile. 1 mile, and this thing is traveling at 315 miles per hour. And this radar, I'm hoping this radar has good intentions. It's not like destroy, exterminate. What's that? Okay. Let's see, this is 1,800 feet. And this is 2,400 feet. And what we want to find is the variables of interest. And the loop-de-loop-de-loop. Oh, wait, so, and is speeding up. So not only that, but is also speeding up at 10 feet per second squared. So, okay, so let's find some information. First thing, I'm going to find the velocity in feet per second. So that's 5,280 divided by 3,600. I should just memorize whatever that is and just start using it, but I'm not going to. Why start now? Unless it'd be, so it'd be 1.4667 is what I would memorize if I was going to memorize what that is, but I'm not going to. And so we had 462 feet per second. I'm going to get theta. In a minute, I'm going to get R. Actually, I should. This is probably a 345. We could almost always a 345. So much so that like I could probably do it without having to. No, it's not. I don't think it is. No. Made a liar out of me. No, it is 345. Sorry, 36.87 degrees. Yeah, 345 triangle. I hate that. Don't like them. And the R, though, we could do this in our heads, but I'm not gonna. $3,000 feet. Let's see, what else? Preliminary things. Well, we could find out what the acceleration in the normal direction is. It's going to be v squared over rho, because it's going through dipping through a curve, so it's got an acceleration. It's going to be vertical. So that's 462.0 squared divided by 1 mile, or 5,280. So let's square that, and 5280, boom. So we have an acceleration of 40.42. That's good enough. Yeah, feet per second squared. So here we go. We're going to write acceleration of the thing is going to be, is it speeding up? Is it speeding up? Yes. So we're going to have 10 ET plus 40.43 EN. We could also write out without having to do anything else that it's going 462.0 ET feet per second. Now we're ready for the coordinate transformation. So let's see, we got a ruler here. We're going to start out with this guy, and he has an EN right there and an ET. ET, found home. This has an ER right here. Now remember, it always go to the left. I was really second guessing myself. Yes, it has to go to the left. That's because it's always counterclockwise, right? The angle's always counterclockwise, so the angle has to go to the left. So this was kind of a weird one to have as a vector, honestly, because it's really sort of an angle that's saying, hey, you're going this way. It's fine. So in plugging those two on top of each other, and then, so this is not like any of the exotic ones. I like the exotic ones a little bit better. I know, not good to do that for exams, to try to get something exotic, but for homework, I like them. I don't also want to keep doing the same old.
I would also recognize for this problem that since the plane is perpendicular to the ground, its acceleration in the other one, not polar,
Cartesian? Path.
Path is the same as its acceleration in Cartesian.
Yes, but I mean they're aligned with each other, but recognize that most of the time it would be.
Yeah.
I mean, we have an acceleration because of the curvature of the thing that is for path, right? But it's aligned with it. But this should be the same angle right there, right? That should be the theta. Looking up from that. So this was ET, this is EN, ER, E theta. So we can even make a neat thing of this, right? Kind of neat. Relatively neat. Oh, no, there's no I's involved in this one. E-T, phone home, E-N, yes, E-R, E theta. So, T, it's going to be cosine, right? T to R. We go R to EN. I'm losing it. Must be sine. Positive sign. Okay. There's been late. It's already late in the day for me. We'll see how loopy I get in the next hour. ET should be negative sign. And then lastly, EN should be cosine. So, in terms of velocity, we'll take the velocity as ET, and this is going to go down this way. So we'll say that it's going to be equal to 462 times cosine of 36.87 ER plus 462.0 times negative sign. I don't know, put a negative. I'll put negative right here. No place to put it. Couldn't fit inside that. Sine 36.87. Whoops, sorry. E theta feet per second. And then, so first we'll get V is equal to 462 36.87 cosine times 369.6 ER. So that's going to be R dot in our variables of interest. (462) we go 36.87 sine times negative 277.2 E theta feet per second. So our variables of interest over to there, we have theta is equal to 36.87 degrees. R is equal to was it 3,000? No, yeah, 3,000 feet. R dot equal to 369.6 feet per second, and theta dot is going to be equal to V theta divided by R, or negative 277.2 divided by 3,000. Negative 0.09240 radians per second. And now the hard one, we're going to go acceleration and do the transformation of it, but it's just, ain't nothing to it but to do it. And it's like those kinds of phrases, I'm sorry. Kind of sound like stupid though. Okay, well, don't worry about it. 10, let's see, we'll start with the ET. I'll just start with the ER. I say we got times the cosine of 36.87. Much easier to do the other way. And then plus 40.43 times the sine of 36.87 ER plus 10 times the negative sine of 36.87 plus 40.43 times the cosine 36.87 E theta feet per second squared. Math happens. It's not like shit happens, man. It's math. You're hilarious. Start singing or something. I think it did that right. I feel like it did that right. All right. 26.34 E theta. And now that we have the components, we can solve. We'll do this first one. That the idea of that one is AR is equal to R double dot minus R times theta dot squared. Therefore, you can find R double dot is equal to this value, 32.26 plus R, which is 3,000, times theta dot squared, 0.09240 squared. Boom, boom. Running out of paper. 32.26, 0.092. Can't read my own handwriting. Where'd you go? 404. Don't worry about 0. Squared times 3,000. 3,000. Add them together. Add it up. Add it up. You guys are not big Violent Femmes fans, I bet. The Violent Femmes. Interesting 80s band. It's good. That song actually, its main chorus has a very. I think it has a naughty word in it. They also one of their famous songs is I can see I'm meant to be let me go wild like a blister in the sun. Let me go wild. Big hands, you know you're the one. So now you know that. That's great. I'm so happy to know it now. We can get the theta double dot plus 2r dot theta dot Coriolis. So we can solve for theta double dot by taking this minus that divided by that. I think I did that right. This minus that divided by that. Sure. So that is 26.34 minus 2 times theta dot, which is negative. No, r dot. Where the hell r dot? Where'd you go? R dot. Oh, there. 369. 369.6 is supposed to be 9. And then multiply by theta dot. So I'm going to have to put up violent femmes. But I have to be careful because there's one I can't remember. I think it might be added up. Added up might be the one where the verse goes, why can't I get just one? And they said the bad word. Why can't I get just one? And I thought in the bed, and I'm damn dead. Add it up. So they're kind of a punk band. They only had like acoustic guitar, stand-up bass, and a guy with a snare drum. That was it. It's only a 3-piece. They had little catchy little tunes. Anybody that was cool. Actually, most people that like them are way cooler than me. I'm not cool enough. Are 3,000. I'm going off the rails, guys. Just have to, this is going. This is going downhill like really quick. Just so I'm going to still try to have some usefulness out of this, though. But I don't think anybody should ever watch this video or listen to it. Maybe we can pretend. Let's turn the sound off. We'll just play Violent Femmes in the background. They probably would flag this if I started playing Violent Femmes. Are you not getting the same thing?
I think double checking 26.2.
Well, there's a lot of opportunities to make math here. Okay, so which did you get right? Or which didn't I get right? Which ones don't agree?
I got different values for both here. I doubled that and they doubled that.
What number is this? She's 169. I got the R double dot correct. I don't have the R double dot. R double dot, not theta double dot. How do I do theta dot? I got that right. R dot's a little off. Well, they rounded up. They rounded up. So they went to 370. It's just theta double dot. And
yeah, that's what I got for the answer. I think you just put the calculator.
Maybe I could have. Maybe I left out the 2 or something.
I got the same value for the R double dot, not that I fixed them.
This looks like it should be right. That minus kills that minus, right?
Yeah.
Maybe.
Yeah, I did the same calculation. I got the same numbers. It's just not the value.
369.6.
I think you're right. I think we're all saying the same numbers here, so.
You get your value if you multiply the whole thing by 3.
Maybe I divided by 1,000.
Yeah, so 3,000.
Yeah, that's what it was. I got so excited about getting near the end. Not a finisher. Just not a finisher. 3155. I'm about to sneeze. I know I can tell it. It's like imminent. Imminent. Especially when it doesn't go through.
I look at a light. I don't know why, it just hurts.
This is a rarity for my wife, though. My wife, ever since she was a little tiny kid, will sneeze 10 times in a row. If she sneezes at all. Goes, choo, 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 choo. And they used to count, like in grade school. Everybody in the class would start counting to see how many it would be. And she'd get like totally embarrassed. She'd get totally embarrassed. So what she would do, instead, she started internally sneezing. And this can't be good for you. She's trying to hold in the sneeze. It's so funny. It's so funny to watch. But if she lets it out, she says, chew. Chew, 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 chew. It's awesome. It's awesome. I love it. Never stops being funny. All right, what are we doing next? It's a great video. This is going to be awesome. This one's going to be awesome. They're just getting better every single year. That was a Beetlejuice reference, by the way. You ever watch the Beetlejuice? He gives his resume. Well, I attended Juilliard and blah 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 blah. I watched The Exorcist 850 times, and it kept getting funnier every single time. Yes, Beetlejuice. They made a play out of it. And Lauren Bobart just got kicked out the other day in Colorado for vaping and singing along. Congressman Bobart.
I don't know why I wouldn't have expected her to watch that show.
I don't know anybody vaping during I don't know. I'm not judging. Just saying. What are we doing? We can do. We had some good. That was a good hard problems. That's good. It was good to have difficult problems. Do projectile motion problem. You do a difficult projectile motion problem. Got like a doozy in here somewhere. More coordinate transformations. Those are. Because that was an easy coordinate transformation.
What about
11.109. You know how brave it is of me to do this? Lay it all on the line. I could look like a moron. I don't know what I'm doing. Ooh, what the hell is that thing?
Yeah, I don't know. I take back that.
We'll take back. No, we can totally take back. I don't know. It looks like it's good. They got some kind of water hose that are making that thing into a turbine or turbine. I don't like the word turbine. I can't pick up this ruler. I can't pick it. It's stuck on the floor. It's gonna be stuck on the floor. Oh, I got it. It's gonna be stuck on the floor forever. Yeah, it looks like it's like a hose. A nozzle at A discharges cooling water with an initial velocity of VO at an angle of 6 degrees with the horizontal onto a grinding wheel. A grinding wheel. Okay, cool. I got it now. In diameter. The range of values. Oh, wow. Two bullet points B and C. It's not terribly difficult, just a little annoying. It's pretty much the same problem as this. Because all you need to do is put together the equation and then put in these coordinates of where B and C are, and you could solve for what the VO is. This one, I thought, I seem to recall this one really kind of bugging me a little bit. They give it the red. They get some of the red too. If red means hard, red means difficult. Maybe, I don't know. Here's an interesting one right here. For one thing, is that they're doing two problems in one. It seems to me. First off, they're like, you're getting a coordinate right here that it has to go over, right? So you have this unknown, and then once you have that unknown, then you figure out what the distance is. You see what I mean? But I already did your aha moment. That was your aha moment. I already described it. Right? But I saw it there, and I'm like, oh, I see what you're doing there. But the way to prepare is to, like, keep pushing yourself to find things that you don't know how to do, and then hit an aha moment and go, oh, I got it. And then just pay attention to the details in between to get to the end. Ooh, there isn't enough pulley ones, but that's all right. Pulley problems. There are a couple of pulley problems that are really tough. There's a couple with tricks in them. I don't like I don't like trick problems, but you could make a case a lot of these are trick problems, but I don't like pulley problems that are trick problems. But there is a couple itty bitty tricks. We don't do the graphical method. Let's see here. Curve linear product of condition here. I guess pulley problems are second. It was the second class, right? It's funny. There's a lot of books that don't have the pulley problems in them. Leads you to the question: should we even be doing them if not every book has them? But maybe they're not necessary. Maybe you could live life without having a pulley problem repertoire. I don't know. This one looks kind of crazy. This one I think has a trick to it. Yeah, this one has a trick. I can't remember what it is. 1151. This is a whole different thing I hadn't taught. And I don't know why. There's a lot of books that have a similar theme in this, but this is like the only problem in this book that has this type of thing in it. And one of the interesting parts is that the angle is constantly changing in this. So I'm trying to remember what you end up doing right here. You can turn it into the horizontal. I'm trying to remember how to do that. But Dr. Orlick would I think he does an example with that in there. But there's no other ones that are identical to that. No. It's a weird problem. I don't remember what the premise of it was. We got these over here, over there. This used to be a homework problem. Because it has two ropes. It's got 1, 2, 3, 4 degrees of freedom, and I think it has a relative motion part of it. It's too difficult to be an exam problem. He said, hoping he never asked it as an exam problem. Oh, here's a weird one too. Yep, this because it's attached here at the bottom. That can throw people off. All right. 1156. All right, I'll have to try to remember. How does that? You know, but here, I know this is my personal central focus here, but I really, really do believe everybody who's an engineer should do their utmost to become better and better at drawing. And some people are like, I just don't draw well. I'm like, well, change that. I wish we could have more drafting here that would actually give people a lot of practice. Yeah, well, we have like just sort of a partial one. Yeah, I taught it 3 years ago.
Change it so like now it's like not drafting or not like hand drawing.
Yeah. Well, I tried to change it, but that was so it would have been before your time that I tried to change it. Where I still want, pushed hard for the sketching aspect. You want to do a little bit of combination of sketching and hand drafting. And then I merged the hand drafting with some AutoCAD stuff and made enough room that we had 6 of the 13 classes were SolidWorks. But it's still, it's only a 2-credit class, 1 day a week. Just don't think somehow that's enough. My school, we were on the quarter system, which doesn't exist much anymore.
My school was like it was divided into quarters, but you didn't have any quarter-length classes. It was all.
So they have semester classes, but they say there's quarter.
Yeah, so like if you had a semester class, you would still have like a quarter spot.
Yeah.
Well,
so you always have like a midterm, not like a quarter one?
Not necessarily, no, because like all that have to do with classes are like June and stuff.
Yeah.
well, we would have a summer. Some schools have 3. They use 3 quarters a year, and then the summer is a quarter. Most people don't take. But because we went out to sea for a full year, and we would squish the 4 quarters into a year. So they 4 10-week periods with a finals week after each. It was rough. We didn't have much of a summer. It was like no summer at all. So all the breaks in between and stuff like that would be take up the summer. Okay, so anyway, let's see the given here in 1156. It's a function of time. Look at that. Check it out. Okay, A and B start from rest. Color A moves upward with an acceleration that goes like this right here. 3t squared. Start from rest. I wonder what that noise was. Oh, no, I know what that noise is. Okay. I'm still connected to my computer back in my office. It dings when I get a... okay. Knowing that color B moves downward with a constant acceleration, right? And this is upward. This is A. B, constant. It doesn't say what it is, but it does say and that the velocity VB is equal to 150 millimeters per second at constant downwards at delta YB 700 millimeters. All right, so now here we got to find a acceleration of c as a function of time, b, the distance c will move at t equals 3 seconds. Whee! They mixed some things up. Way to go there, Mr. Beer. Or was it Johnson? So I think the thing I want to go for first is the relative motion. So I'm going to start. This is tough. Okay, so here you go. I'm just going to go across this line right here. Right there is my reference line, and I'm just going to be bold. I'm going to go, this is SA, that distance. Here's a trick. Make this SD. Make this SC. Oops, I don't know what the hell I'm doing there. I don't have a great place to put it, so I'm going to put it in a lousy place. Right in there. SC. I have no idea who you are. Okay. And then lastly, SB. All right, so we're just referencing the same line coming all the way down. And now we want to find these lengths. So I'll start right here. So this length right from here to here is going to be SD minus SA. You agree with that? I don't know this strategy is going to work, but I think it will. All right, now we have this length right here, and that's going to be, so I like to put in parentheses, go plus. All right, so that's one length right there. Now I'm going to do this length right here, because this is not the same as this one right here. And that's going to be SC minus SA. In between there, you guys okay with that? Now we have this one right here from here to there. That should be 2SC. And then this last piece right there should be SC minus SB. Man, I feel as though I'm doing something wrong, but that's the best of my recollection here. Notably that SD doesn't change. So when we take the derivative of that, the SD is going to go away. I'll rewrite the thing out anyway. So we go SD minus 2SA plus 1, 2, 3, 4SC minus SB. You okay with what I've done? Any questions? You can contradict me because I don't know I have the right answer, by the way. I don't know I'm doing it right. All right, I'm gonna go ahead and take the derivative of it. SD goes away, remember. So we're going to have negative 2VA plus 4VC minus VB. And then take the derivative again, negative 2AA plus 4AC minus AB. SD never changes.
Right, okay.
That's like, if you were going to say there's a trick that maybe, because it's different than other problems, it might not be, you might not be aware, because you haven't done a problem like that, that you should, take some reference like that and then subtract out the thing. But I seem to recall it. So that kind of makes it a trick, right, on one level, but only in the sense that you may or may not stumble across it because you hadn't seen it before. Our first goal is to get the acceleration as a function of time. That's interesting. But we don't know the acceleration of... Oh, no, we were able to find the acceleration of... I forgot. They gave us enough information to get the acceleration of B. You know, once again, like you didn't want a problem with a lot of words. It's had a lot of words in it. And so you have to read those words carefully, and you could see that like you have an opportunity. It starts from rest, so you could use the equation that the acceleration is equal, the velocity squared is equal to the original velocity plus 2 times the acceleration times the change in position. Right? So we could do that with right here, and so we could say, they said 150 squared, and take 0 squared plus 2 times the unknown acceleration times the distance it moved was 0.7, and so the acceleration of B, and they also said it was a constant and that it was downwards. So 150 squared, 2 divided, 0.7 divided. Whoa! No way. 150 squared. That seems like way too high. Yeah, it is loud. That's loud. That's loud. That's a lot. Was that millimeters per second or meters per second? Okay, cool. That's crazy. That's just nuts. 0.15 squared, 2 divided, 0.7 divided. All right, cool. But now it's a small amount. 0.01607. Did I get that wrong too?
I got 16.
Oh, what did I do wrong?
It's not multiplied by 1,000 millimeters to meters. I think you multiplied by a million.
Why are you doing
Oh.
do it to meters per second, though? Why not millimeters per second? Because all you have an acceleration.
Isn't it wait,
Because my acceleration was in millimeters per second squared.
I got you. All right, so I'm going to leave it in meters. Why? Habit.
Because
A very good habit. Was the other one in millimeters per second?
Yeah.
All right. I'll concede this instance. Maybe. In general, but you're not a mechanical engineer, so it's totally fine with you. You could do any damn thing you want. I don't care. Oh, that's not true. I care, but at the same time. I have filled many lead-acid batteries. My job as a cadet, fill the lead-acid battery. Use the little thing, the little hydrometer. You can find the density of your sulfuric acid, so that you can figure out how. I don't know what the hell we were figuring out. Anyway, I had to take tests all the time and had to put it in the logbook. Yeah, one of these days I'll get there. All right, so we got that, and that's going down. Down, 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 down. All right, so that's cool. Okay, so all we need to really do is plug those into here. So we can, for the part that they wanted, and to here we can go words. 0 equals negative, and then this was 2 times 3t squared plus 4ac minus 16.07. So you could solve for AC, And that's going to be, let's see, that's 2, 6 over 4 is, is that 3 halves? 3 halves t squared, and so plus, and then divide this by 4. And you get plus 4.018. Okay. And then the last one, all we needed to do was find delta yc as a function at time 3 seconds. So what I would say is we should integrate this twice. That's fine, right?
Yeah.
It's at rest at t equals 0, so we don't need to do it adding constants.
But do we have to add the in-between constants? I don't think so.
No, because velocity at t equals 0 is 0.
Yeah, yeah.
And changing distance, so we start at 0.
Yeah, so we could just go ahead and go velocity is, acceleration is equal to dv dt. Doesn't hurt to do it the right way. And then go dv is equal to a dt, integral, as you mentioned, 0 and 0, v and t. And so we'll go, okay, the velocity, that's what this equals over here, integral, and so that's going to be 3, and then 1/3 on the front of it, so it ends up being 1/2 t cubed plus 4.018 t, and then no constant there because that's 0, yeah, okay. And then do the same thing here with the velocity is equal to dy dt, and go dy is equal to v dt, integrate both from 0 to y and from 0 to t. So we're going to have y is going to be equal to, that's going to be 4th, so it's going to be 1/8 t4 plus that divided by 2, so we're going to get 2.009er t squared. I do anything wrong? So at t equals 3 seconds, this is how loopy I am. I put a t next to there instead of seconds. So 9 times that, and then 3 to the 4th is 81 divided by 8, and then add, and so you get 28.21. And I'm guessing these are millimeters. No? Yes? No?
Isn't the acceleration of v downwards?
Oh. Yeah, it sucks. So should that make negative right there? You know, see, I think you don't have to do that. Oh, wait, no, wait. Yes, you do. Fudge.
You just flip the sign.
You could. I'm just going back up to here and seeing that that's negative and that's negative. So yes, you do need to put the thing in there. What I was about to say was like, A's going up, B's going down. A lot of times it'll be inherent in there. Like if this was positive and that was negative, it wouldn't matter. Like you would be kind of like already going, they're already going opposite. Yeah. Oh wait, they're already going opposite. Yes, they're already going opposite.
Yeah, because one's going up, one's going down.
So, like, because if you brought this over to that side right there, if it was just A and B, just if you just had this right here, like to make that negative and make this negative,
Yeah, okay.
one would go up and the other would go down.
Got it.
That's a dick move on their part. So, because they have the same sign right there, they're already inherently, I think. Let's just see. It's good. I mean, by the way, unfortunately, in this world, solution manual isn't always right. Sometimes what you gotta do, you gotta freaking model the thing. And they go, I don't know, I've had this, a little obsessive streak in there, but it's kind of fun to actually care, though, right? And I don't know, that's hard to convince people to some extent. They're just some kind of crazy nerd or something. Which actually, like, I am going to find the answer to this whether it kills me or not. Is there something pleasurable? I can't keep missing it. Is it 56?
56.
You won't pass it.
Right? No,
Oh, wait. Different color.
Messy.
I just want to say something that says
So they put a negative right in there. Huh? Oof.
that's what I got.
Yeah. I personally disagree with him this right now. I don't know. Not feeling it, but we both have negatives. See, one weird thing here is how come they're making this negative?
Figuring circles out how late I am.
It's because one of the reasons because they decide they're doing the thing that I avoided doing, where you're going to like stick to this coordinate system that you defined in the beginning. So what they mean is that negative, it means it going up, because the coordinate system is positive downwards. But personally, that just means I don't think it really means anything, because you can just like multiply everything by -1 once you get to the equation. So it doesn't really matter what's up and down, just what's opposite from each other. But I guess you do need to make B positive somewhere in there. So make it a positive value. Yeah, honestly, I disagree with them. Because of, well, whatever I would explain. But what good is that going to do? I have to build the thing and check and test it out. Right? It's the destination. All right, so you want to call it, or you want to do this more? You need more out of this? Yeah, I do it all the time. What's crazy is the one inside the next door office suite where my office is like almost 420.
See, what you got to do is you got to get a professor to schedule his exam in this room.
How many thermo in this room?